Good afternoon, everyone. Welcome to our Industry 4.0 IoT and the post-COVID-19 manufacturing landscape event using the Remo platform. My name is Ben, and I, along with Steve Melito, we're going to be your masters of ceremony today. Before we begin, I'd like you to turn your attention to my lovely colleague Paige, who is going to give you some technical tips and tricks while using the Remo platform. Paige.
All right, good morning, everyone, and welcome to Remo, our virtual event platform. You may have noticed that Remo is very different from other online platforms. When you enter the event, you are going to be dropped into an open seat on the first floor. To move tables, I'm sure as many of you have found, you can simply double-click on another table you want to join. You can also move floors by clicking the highlighted floor numbers in your menu bar on the left side of your screen, and you can move to that floor. If you're having trouble reading the table labels, you can, if you have a trackpad on a laptop, pinch zoom to increase the size of the event floor. And additionally, you can pinch shrink. And then if you have a mouse, you can simply scroll in and scroll out to increase and decrease the size of the event floor as well. When moving between tables or between floors, your camera and microphone may take a second to reconnect. That's just a function of the remote platform. You can also click on different avatar bubbles to see a person's name, contact information, and even send them a direct message. You'll also notice you have a toolbar along the bottom of your screen. You can use this to send messages to the general chat that everyone can see, the table chat that only your table can see, or direct messages that only you and the other person that you are messaging can see. Additionally, if you find that the table maps are hard to find, if you click the white space between tables and just drag the map up a little bit, you'll see along the bottom of the event an event bar with a couple of banner images. The one all the way to the right has event instructions with enlarged maps that you can use to navigate the Remo event in another web browser. At any point throughout the conference, if you feel like you'd like to take a break, you can go to the first floor and sit at one of the grab and cup of coffee break room tables to take a break and step away from your computer. Enjoy the conference, and Steve, I'm going to invite you to take away the event.
All right, Paige, many thanks. Hi, my name is Steve Melito. I'm a solutions specialist here at FuseHub, and I'm going to be the MC for today's event. And at this time, I'd like to quickly review today's agenda. So for starters, there will be an hour of speaker presentations followed by 30 minutes to network with manufacturers, MEP centers, and other Industry 4.0 resources. If you have any questions for our presenters, please hold them until the networking phase of the event, where you can find them at Q&A tables on floor 1. Now, today's event is being brought to you by the Manufacturing Reimagined series, a New York Manufacturing Extension Partnership program. As part of our mission to support New York's many small and medium manufacturers, the Manufacturing Reimagined series will offer further workshops in addition to one-on-one discussions for a customized resource report and potential funding opportunities for your Industry 4.0 project. Now, I would like to introduce our keynote speaker, Carol Thomas. As Director of the Manufacturing Extension Partnership, Ms. Thomas leads a nationwide network of centers that are focused on helping U.S. manufacturers strengthen their supply chain integration and access new technology, thereby helping them to compete globally. Carol Thomas, please.
Hi, thank you so much, Steve. Thanks for the wonderful introduction. I really, really appreciate it. And welcome, everybody. This is quite exciting. I don't know if you all are doing this, but I'm not. This is new for me. So I really appreciate you all joining in. And some of you know me, but I don't think a lot of you do. And just to give you a little bit of background, I love to have new things happen, exciting things happen, different things happen. I love the dramatic because guess what? That's when you have opportunities. That's when something new and exciting can happen. And so you can imagine with everything that's going on right now, just how excited I am because all kinds of new and exciting things happen. I remember as a kid, me and my sister, we were up on the 3rd floor and we put together a little basket of sandwiches for our friends and, to make a little money, and we rolled it down the window and folks would put their money in, and then we'd bring it back up and bring them down their sandwiches. We were okay until my parents found out that we weren't really making a lot of money, but we were spending a lot of our food for this little business we had. I always got into a lot of trouble with some of my ideas, but at least it was fun. So again, as you can imagine, what I'm doing right now is truly embracing this unexpected, the positive changes that are coming out of here, the things that bring out opportunities that normally wouldn't happen unless something like this is going on. And so I'm just going to talk to you a little bit about what lies ahead. Next. And so what lies ahead? When we look back at this year, we're going to look at, okay, in the year 2020, some of you remember January was quite shaky. February, a global catalyst erupts. This is when there's both social and political landscape changes, a lot of profound changes, moods change, thinking changes, perceptions changes. By the time we got to March, if you can recall, some of you may know that we had the largest single 1-month drop in manufacturing in 74 years. I mean, nothing like this in our lifetimes has happened. And then the whole shutdown, opening, shutdown again, all the uncertainties that happened with us started to go on. But just before this all happened, we were in this environment of Industry 4.0, all this new technology, cool stuff was going on. In manufacturing, though, things were still, the second half of 2019, there were some things that got people a little bit nervous, even with the new technology, and people were trying to figure out what exactly should I be doing. A lot of nervousness in the small and medium-sized manufacturers, a lot of angst about, okay, what does it mean to have a smart factory, using robotics, 3D printing, Internet of Things, and, that whole thing. What happened with this first, I would say the last 5 or 6 months, a lot of vulnerabilities in the supply chains, in our just-in-time inventories that we were taught so much to really get in, to use that. The other thing that happened too was that between 2007 and 2016, there in the Great Recession, as that was going on, we lost 70,000 manufacturers, and that had never really been exposed until we started to need some important materials, some suppliers in areas that helped us to help us through the health pandemic. Next slide, please. And with this exposure of what happened and the loss of some critical suppliers in the U.S., a lot of economic uncertainty is starting to pop up. And even more so as we're not sure where are we in this continuum of the pandemic, of the economic disruption, also with what was going on with trade and what is now going on with trade. The whole energy industry, but particularly the oil industry, the bottom fell out. Retail, entertainment, all of those areas, aerospace, automotive, all of those areas that impact suppliers and various different supply chains. The level of uncertainty that we are at now is palpable. Many business owners are hesitating, so to what comes next, what should we be doing? But we really won't know what comes next until it actually happens. So, I want to take a poll out there for you all that are listening. I think we are savvy enough technology wise with this Remo that we can take a poll, I understand. So my poll is, so if you could have a superpower to help you in this next 12 months, what would that superpower be? And there's a number of choices and you can choose and we'll get back to that. But I want to know, if you had a superpower, what would that superpower be? And so next slide. We're going to say we don't have that superpower right now, but what is that path forward? In absence of that, of getting a superpower, what can we do? And so what I thought about in all the things I read, all the places I go across the country, is observing. Now, there was a gentleman by the name of Yogi Berra who said, one of his funny, famous quotes, you observe a lot by seeing. It was one of those kinds of things that, like, yeah, but he just said, never mind. So observing is a very important thing right now. Just sitting back, and I know as business owners, a lot of times you don't have a chance to do that. What I have employed my mother and some of the grandkids, can you just help Aunt Carol out or whatever, to find out what's going on, because you're going to need to observe things, looking in various different industries, various different levels, piecing together what could happen. We really have to take the time to do this. And what's going to happen, what influences what's going to happen, will come from many different areas. So observation is going to be very critical. In what's going on. And then connecting, find those avenues that can fit into your business routine that allow you to connect with other business owners, with other organizations that, these organizations will have the ear, the pulse of what's going on. To pick up the subtle changes that are happening that are going to influence what's going on. One of my favorite books came out in January of this year. And the interesting part about it was that it came out in January of this year. It's called The Non-Obvious Megatrends by Rohit Bhargava. It talks about how to look at these things, how to observe, how to talk to people to figure out what are the real trends that are going to happen here, because you're going to need this kind of information to help you. Another thing, explore complementary markets, explore complementary industries. For instance, we held, the National MEP held a very recent conversation with manufacturers. And we had a gentleman on there who, his company manufactured stage lights for Broadway. All kinds of lights that were either in the orchestra section or in the back. And he explored complementary markets and was able to become successful in doing that. The complementary market that he explored was the restaurant industry, with a lot of the al fresco dining where, it's better to eat outside during this period of time. He approached a lot of the restaurants about outdoor lighting, about, giving it a dramatic appeal to get people to come into restaurants. And it has been successful for him. So looking at areas that you wouldn't normally look at is going to be very important. And then investing, which is going to be the hardest thing to do, because you will not be able to invest and feel good about it unless you have a little bit of an idea and this observation, making connections and exploring. So invest where and when you can in areas that help support your agility, your adaptability, things that will allow you to pivot if you need to or if you don't. For instance, if you have staff that you know you're going to have to let some folks go, or you're going to need some new staff to pick up, for maybe some new areas that you hadn't been producing for before, but now in this pandemic, you're producing things. Try to pick up those folks, the staff who are competitive in areas such as, of course, digital savviness. Folks who are future oriented, who understand what could be, coming up next. And so, next slide, please. And so here is just very briefly what other companies are investing in. This comes from the National Center for Middle Markets. These are the companies between 1 million and 1 billion, depending on what industry you are. They're the middle of the market. They're the ones that don't have the largest amount of employees or the smallest amount of employees. I would say between, and this is a large, gamut, between 50 and 2,000. Cybersecurity, new composites, advanced process controls, of course, robotics and automation in any way, additive, embedded sensors. These are all areas that companies are investing. Now, if you look at this chart, though, this was prior to, of course, everything happening with the pandemic, but still, this is future oriented. Now more than ever, investing in the future is going to be what gets you into being ready for the new normal. And it's a great time to invest. I saw the other day, because, I'm doing the whole national MEP center from across the country, that there's a company in California that is selling refurbished coordinate measurement machines. And so you say, well, how do you know that? Next slide. Well, I know that because the real secret superpower that you all can have is in the MEP National Network. And so I don't know if there's a way for us to see what superpowers you all chose, but I can tell you that the MEP National Network will help you have all of those superpowers that you're looking at. A way to look at the future. We have nearly 1,400 people who really understand what's happening in manufacturing. They eat, breathe, sleep. I mean, all they do is manufacturing. And you are in New York, but you have advantages because this is a national network to tap into what's happening in California, tap into what's happening in Florida, tap into what's happening in Hawaii or Puerto Rico or Wisconsin or Nebraska. I mean, you can do this because we're a national network, and they can keep you up to date on maybe there's some incentive plans that a state is giving, or new stimulus funds from the federal side. They can help you find those digitally savvy workers that you're looking for to help you invest in your future. And they can help you change how you manage your suppliers and how you are in your supply chain to help you with predictability and resiliency. Find those digital tools to help you manage your network. So going forward, you're going to need this superpower, and you're going to need real-time data to help you understand what's going on, so that you're not going to necessarily see the future, but you will be able to get as close to it before others do that. That'll help you understand what's going on. So next, I just want to say, next slide, thank you very much for having me open up this incredible event. Everybody's done a fabulous job in doing this, and I hope you take the time to observe, to connect, to explore and think about your investments. So thank you very much for having me here to do this today. This is so exciting. This is something new, and you know, this is something that I love. Thank you.
And Carol, that was fantastic. Thank you so much.
Thank you, Steve.
So our next speaker is Dan Radomski. Dan is currently the director of the Lawrence Technological University Centropolis Accelerator, a program that helps accelerate small-scale manufacturers and innovators of new hardware products. Dan is a Fuse Hub advisor and has served as a developer for the Department of Energy, Lawrence Livermore National Lab training curricula that educates product developers and companies with hardware-based products on how to scale their business. Dan, welcome.
Thanks for having me. I appreciate it. It's been a pleasure working with Fuse Hub and the MEP network in the state of New York. Today's topic of Industry 4.0 is a little bit daunting in many cases to manufacturers. Just getting their arms around the different technologies that are available, how to implement them, and the practicality of how that even disrupts their existing workflow and manufacturing operations. So it's quite common to be a little bit hesitant to look at some of these Industry 4.0 technologies. Today, I'm going to share with you some what I consider some of the more practical I4O technologies that we're seeing implemented already today in manufacturing operations, maybe not broadly across enterprise-wide, but certainly in pockets with both small and large manufacturing firms. So I'm just going to share profiles of some of the companies. And these are companies that I've been personally working with. We launched an Industry 4.0 accelerator, the nation's first, and we have companies from all over the globe applying to be engaged and to specifically seek support to proliferate these technologies into US-based manufacturing operations. So as we go through this, we'll make this presentation available afterwards. And all of these slides, if you click on the photos, it'll take you right to a more detailed video presentation of how these technologies work in action. So first is Autaza, a company out of Brazil, also has operations in Michigan. What they've developed is a kind of a unique inspection system. It combines cameras with lighting to be able to accurately determine flaws in painting and coating operations. Why this is important is in many paint booths, whether it's liquid or powder coating, often you have rework where you have to put the, in this case, the fascia in a vehicle back in to have work done again. And obviously that rework causes time and money, right? So being able to indicate in situ and then have another robotic arm go back in and touch up the areas that are imperfect is a great use of advanced technology. They also have a computer-aided engineering simulation system that does the same thing you see here listed below. And what that actually does is simulate through lighting and camera systems imperfections, particularly important for stamping applications, to be able to determine through issues of, spring back and other issues, how to make some adjustments in the tooling before you spend all that money in cutting the tooling, which can be quite expensive for stamped tooling parts. There's another company out of California. We're seeing quite a few of these implementations with just very low cost camera systems, and then using artificial intelligence to train the difference between a good manual assembly versus a bad manual assembly. So obviously what you need to do is stage, at least in this case, only 5 good assembly operations. And then the camera system with their unique algorithms picks up different areas on the manual worker, the hand, the wrist, the elbow, shoulder, facial features, and can tell you real time if you missed a step or if you made an error in the manual assembly process, and then immediately notify the worker so they can avoid downstream defects in the parts that are being assembled. Capture More, another company out of Michigan, is using QR codes in their unit called Tool Stats to be able to track accurately tooling. Many cases, manufacturers have tooling at their contracted tier 1 or tier 2 operations, sometimes lose track of how they're sent along further down into the supply chain. So this accurately not only keeps track of the location of your tooling, but also the condition of your tooling for inventory, or using steel, aluminum, zinc, kurzite, and then the lifecycle expectancy, meaning how many shots are left before it needs to either be reworked or replaced. Infinite Foundry, there's actually quite a few companies, including companies in New York. This just happens to be a company in Europe that does digital twin development of plants and work cells. And what this could be particularly helpful for is when you're trying to either during or even before setting up operations and being able to do some workflow simulation to optimize workflow and standardized work procedures, including what you can do once you have a digital twin of a work cell or a manufacturing facility. You can even use this for virtual training for standardized work or safety training before new workers come on the job. Another interesting technology, DeepHow, a company out of New York, is really addressing what we see as a skills gap in the manufacturing environment, where we have an aging workforce that really knows the tricks of the trade. And basically, again, use any camera, including your iPhone. You take videos of the expert explaining their work step-by-step instructions, whether it's working on a machine or it's doing inspection, and captures that video in a easy to digest and easy to categorize from any tablet or device on the shop floor. So basically, very quickly getting to the procedure you need to get to. If anyone's been in the work environment and worked standardized work procedures where you had these large books of printouts, this is a much simpler way and quicker way to get to the instructions and details that you need. Parasense, we're seeing a lot of industrial Internet of Things technologies, particularly sensors that you can integrate on just about any legacy equipment. So many machine tools that are 7 years or older do not have data collection systems. So using these types of sensors, being able to capture accurately temperature, electrical usage, vibration, and other measures can give you a good indicator of when you might expect downtime. Vibration on a spindle might be an example of that, temperature on a motor to predict when you might experience failure, and then have preventative maintenance schedules built into the dynamics of using that data. We're also seeing companies that are trying to use wearables to help with manufacturing efficiencies. So Live Goggle is a company out of India that has a kind of a hands-free audio-video communication goggle device. So what this allows you to do is take photos, still photos or videos of your operating work environment, as well as to speak directly to capture what you're experiencing either in the work cell or in the case of an inspection. Actually, this is really ideal for inspection and service work as a way to automate all your data collection, right? So instead of having paper for inspection documentation, you literally voice command to a central processing center. Invago, this is another interesting tool. Basically takes any standardized work procedures or step-by-step instructions, whether that's in paper form and or in digital form, and then transfers it to be accepted by any device, and then to voice command the work procedures that you're looking for in a real-time environment. And then it is voice enabled to be able to communicate in voice as well as in type on your device, specifically what the procedure needs to be. So just a great example of artificial intelligence put to work to make it easier to understand what your standardized work procedures are. We're also seeing quite a bit of use of standard, again, visual systems with artificial intelligence built in to accurately detect when we're having safety issues on a plant floor. So this company, Airbus out of Turkey, has already implemented this in a number of operations, including automotive plants, to be able to determine if an employee is not in the location they should be in, and if there are any other safety or precautions that need to be worried about between machinery and human workers. Caster, this is a company out of Israel that already has a really unique software system. It's basically a click and drag 3D CAD files into a software, and it immediately tells you which parts in a product and or subassembly that are suitable for 3D printing and additive manufacturing processes. So it could analyze anything, including something as complex as the robot you see there. And again, it's not meant to be an accurate indicator. It's supposed to be a guide for your engineering team to at least isolate parts that could be considered for 3D printing. It is unique in that it not only considers lead time and cost, but also the stress, strain, strength of the materials that you're analyzing. We're also seeing quite a bit of interesting additive manufacturing technologies that aren't necessarily 3D printing. This is an example of a company that is developing a unique process for dispensing conductive inks. And what's unique about it is you can print these conductive inks not only on polymers and glass, but rubbers, thermoelastomers, things that they naturally don't adhere to very well. So it allows you basically to print conductive circuits. So if you've ever been behind an IP or a dash of an automobile, you'll notice there's a lot of physical wiring, many of which sometimes fail. So the ability to do, printed circuitry on the back or B side of elements in a vehicle or any other type of product, and lower costs and improve, durability is examples of some of the technologies you might see here in the future. We're also seeing the use of unmanned, vehicles in manufacturing plant. And we've seen this. Obviously, this isn't something new that's to manufacturing. We've had unmanned material handling units for quite a while, but we're starting to see the use of UGVs with robotics, right? And that way you can have one robotic that tends to multiple machines. This is a company that has, used this very effectively, especially where you need to avoid having human workers, whether it's hot parts and or, like MRI machines that you would prefer not to have human workers in that environment. And then quite a few AR, VR techniques that are out there in play today. Again, digital twin of the environment, in this case, the work cell, and before it's built, being able to quickly analyze ergonomics, swing of head, safety distances, and ultimately, before you take all that time and effort to develop the work cell, being able to make sure you've fully thought out any issues for operating. You're also seeing quite a bit of inspection systems that will very accurately and quickly determine good part versus bad part. These are generally using AI chips, enabling these intelligent cameras in a matter of half a second if you have a defect in the part or if you have a passing part. Obviously, these are systems that need to train over time. Some parts that can be trickier than others, especially if it's metallic parts. There's a wide variety of different failure points, but we're seeing this adopted in more and more on factory lines, from high volume to even low volume applications. And then we're seeing, again, more wearables, right? This is an example of a hard hat, also used in the energy mining sector and other things, but also in the manufacturing work floor, where you actually can capture voice as well as global positioning to support the the location of workers, as well as allow them to immediately report any issues safety or otherwise, to a central processing and manufacturing operations center. So these examples of just, a few of very practical implementations that we've seen. And if there's any interest, obviously this presentation will be made available. There's websites and then links directly to videos to learn more about their use applications. With that, thanks.
All right, thanks, Dan. I appreciate it. While my partner there we go.
There we go. All right. Dan, you missed all that, but I said many thanks for that. A lot of great information, a lot of great technologies going on. So our next speakers are going to be Bill Pollock and Dan Curry from Optimation. Optimation creates innovative manufacturing solutions for a wide range of industries. Dan has 20 years of project and manufacturing production experience working at Eastman Kodak and has worked for over 10 years at Optimation. He currently leads automation and controls technology along with quality at Optimation. Take it away, gentlemen.
Hi, I'm Bill, and I'm going to give a quick intro to what Dan's going to talk about, which is one of the tools that we use commonly in the Industry 4.0 arena. Now, you've had a good overview from Carol about Industry 4.0 and all the different technologies that are resident in it. And the truth of the matter is that, that was our mantra, as she said, coming into 2020. We thought about the technologies and 3D additive printing and all kinds of robotics and everything. And we're only going to talk about one of them today. Dan's talk is going to be about analytics and process analytics specifically, and how even small manufacturers can get into improving their manufacturing lines. But when we first came into, you can change the slide, these are the examples of the Industry 4.0. We'll go right to the next slide after that. When we first came into this year, we had, next slide, if you would, please. Okay, so we had this mantra that had come down in 1492. Everybody thought the world was flat, and then along came Columbus, and he went on to prove that if you sailed off to the edge, you wouldn't get eaten by a monster and you wouldn't fall into the abyss. And so we had a round globe until sometime after the turn of the century. And then in about 2004, 2005, a guy named Michael Friedman published a book, and his book was called The World is Flat. And it was a business book that taught about outsourcing and global economy and supply chains that came from everywhere, and people all bought into that. And US manufacturing moved offshore. And the next thing you know, we were buying massive amounts of things from different places and moving them around. Then came along, as Carol said, 2020, and everything changed much faster than we had expected. The global economy started to crumble because you couldn't send employees back and forth to China at will. You couldn't import things at will. The stuff that you were planning to buy wasn't available, or was available at huge, long supply chains. And everybody started thinking about, how can we reshore? How can we bring essential things back to the United States? And so things changed around. And at Optimation, we can go to the next slide, we saw things changing too. And as Carol said, all of a sudden, people didn't want the same things. We were classed as an essential business because we have pharmaceutical clients and food clients and other clients that were essential. We're working in hospitals to repair things or build things. But many of our clients came February, March, or April, just shut the doors, sent their employees home. And so we had purchase orders and projects, but no work. And if you have welders and pipe fitters and electricians, they can't so much work from home. They have to go to client sites. So it was a bad time. But then what happened was, in addition to our old clients, a whole bunch of new demands and opportunities came into perspective. So all of a sudden, people wanted N95 masks, and they wanted face shield and blood analyzers and automated meat packaging processing lines and pharmaceutical plants for making fine chemicals and so forth. So So we started writing proposals around this new set of requirements. So we have 40, 50 people who are working on vaccine delivery systems, and they're being funded by the Department of Defense under the Warp Speed contracts where second and third were engaged. And the same thing is true about a lot of areas where there's other opportunities for people. And so if we look, next slide, at the US Manufacturing Index in July, it was at a 15-month high of 54. Actually, in August, I just saw that it went up again. And so manufacturing is resurging. A lot of manufacturing, we'll say critical items are being brought back to the United States. There's bipartisan bills by the dozens that are put out by both houses of Congress to try to get reshoring happening of the essential items. So we think of this as ways to retool, reuse, or build new manufacturing lines. And what Dan's going to talk about is if you start a new line, or if you have an old line that needs more productivity, or if you want to take an old line and make a new product on it, what can you use as a tool to measure the analytics to improve the productivity? And we have a tool that we call Process Monitor. And Dan's going to show you how that operates and how you might be able to use it. So thanks very much for that.
All right, thank you, Bill. And Ben, you can actually go on to the next slide. And really, Bill's given a little bit on that already, so we'll blast on through. There's an example of data from process information that was provided by the Tennessee Eastman Company, and now it's 25 or 30 years ago, but it's a data set that's been provided many times to many different industries and schools, basically, to evaluate a production system that had some problems and just challenged people to come up with new ways to improve the control or go in and look at what was happening on the process to understand what was really going on. So we're going to base this little demo on that data, and we can just go on forward. I've actually presented this in a little bit of a video, so it's going to be automated and you go through and we can talk more, I guess, at the end of the discussion. But this process monitor is basically an overview here of how the system works, and here's a snippet. Basically, it does a lot more than what's shown here, but it'll give you an idea. It looks like it's not progressing. Dan?
I'm sorry, Dan, what appears to be the issue?
It's not progressing through the video.
Okay, let me try again.
And mine shows it stopped at like 10 seconds in.
Okay, I do have one, instead of doing it the fancy way, if you'll give me one moment.
I'm going to give you an overview now of the Process Monitor operating system and show the data that is presented and how it works at a high level. The top left section of the screen you see here are the order numbers. An order is equivalent to a batch. In this case, we're using the Tennessee Eastman chemical data set, and we have 40 batches of information. And for each batch, the parameters show up down below. In this case, we have a good number of parameters that are measured for each batch, probably over 100. And you can see this little bell on the side shows that there is an alarm for that batch. And coordinating with those bells, you come down to the parameters. The individual parameters that are in alarm also have a bell. Feature here, if you click this button, it will remove the parameters for the batch that are not in alarm, the things that are not within the control limits that are defined, and then the ones that are in alarm show up here. And in this case, we're looking at the coefficient of variability for this A feed. The A feed is one of the feeds into the reactor. There are 3 or 4 feeds, I believe, that are going in parallel, and this is the A feed. What we do here is select information for that A feed, and then below that, a trace shows up of the actual measured flow during the batch. You can see here the batch was about 60 minutes long, and in this case, after about 18 minutes, the flow went from 0.25 gallons per minute down to 0. And we didn't expect it to go down to 0. That's not good, which in this case wasn't good. So what I can do here is select other batches. Again, each one of these dots shows information for an individual batch. It's up here, so we're on order number 40. And I've just selected one here. And what's shown on the trace down below, this batch is being overlaid on top of the one that was in alarm. I'll do that for a couple others. And another one over here. So you can see these lines up here. In this case, it's green.
Dan, I apologize. This is it's running now off my machine, and it's starting to lock up a little bit with the platform, which concerns me for the rest of the presentation. Is there a frame you'd like me to go through where you can talk through what's the software? Or do you want me to go to the screen grabs in your presentation?
Yeah, I guess you can do the screen grabs. That's probably the best way.
They say that if you want to make God laugh, make plans. I apologize to our audience for the technical mishap.
Yeah, you can just go a couple more. We've seen these. So one of the things that this does is it basically isolates the parameters that are in alarm, so you can make it so it simply shows what is an alarm. Here's another feature of a 3D plot, basically, that shows the results of the multivariate analysis. So it's a way to gather all of the parameters. There's approximately 100 parameters there, and you can come up with a single multivariate analysis that'll basically show you what the summary data is for that. This plot will rotate around the axis. It's kind of funny, actually, because as you rotate your mouse around, you can see the data from different angles, and it can get you a little bit dizzy. And what the red dots that are down at the axis are the ones that are in control, and the red dots that are further away from that central axis, they're the ones that are abnormal. So the bottom line is, with this software, what it's doing is showing you things that are abnormal. It's basically a simplified version of statistical process control, where you can boil down a lot of information into a small presentation, basically. You go to the next slide. Once you click on one of the dots that's in that 3D plot, it'll boil up, or it'll create this image below that'll show the different, it's principal component analysis. So it'll show which parameters or groupings of parameters have a bigger effect on that multivariate parameter. Go to the next slide. What you would have done there is clicked on the bar that was the largest one, and it basically would result in this one. So these are different parameters, where the top one on the list is the coefficient of variability. I know it's a little frustrating because it's very hard to see this. So I know it's going to be a bit hard for you to understand everything that's being shown. But again, this is the coefficient of variability is this largest bar, and that is the parameter that we originally saw in the univariate analysis. So the thing you do here is click the mouse on this largest bar, and it'll go to the next slide. And then it takes you back to the univariate chart, which basically shows you that the one in the upper right quadrant, it shows you the one parameter that's in left field. And that's the one that's created by the chart down below. These are it's a temperature trace, basically, of the parameter of this A feed. And what this shows is about a third of the way through the batch, in this case, the A feed just stopped. So one of the ingredients into the reactor stopped flowing, and it ended up having bad product result because of that. The other lines are like 3 lines in this bottom right quadrant that show fairly uniform value. Those are normal. And then this quickly just shows you the one that is greatly different than the others. The main thing we're trying to get across here is that you can take a lot of data. There are 40 batches with 100 different parameters each. Each batch takes about an hour to produce. And you're able to boil that down to an overview screen with control charts that are already set up. This basically will create the control charts for you. So it takes very little work to get a quick overview of what is happening with your process. And then when something does show up as being abnormal, you can basically just click on the parameter and it'll show you what the contributing factors are, so you can quickly analyze what's happening and you know what to work on to make things better. So that might be the end. You can go forward, Ben, and see if there's, yeah, I think it is. So Bill, I don't know if you had any other concluding comments. That's the basic result. It's boiling a lot of information down into simple overview for you to analyze what's going on in your process.
So Bill, I think you're on mute.
Yeah, you're muted.
Trying to be like you, Steve, and talk without a microphone. All the listening people. What? Those people who are interpreters caught it all. What I was going to say is that Dan showed you a chemical process, but we can do this on all kinds of mechanical processes, roll-to-roll processes, or almost any kind of manufacturing plant. This is an analytic tool that fits really into the Industry 4.0 piece, but you can enter it at a very low level with low cost for licensing, and it can save a lot of money. So something to look at, but if you have any interest at all, obviously you want to have a real conversation with Dan face-to-face and ask questions. And if you have any other kind of manufacturing process, we're always happy to talk to you about those as well. So thank you.
Bill and Dan, thank you. That was great. Really happy to have you here today. And I just wanted to let everybody know that we're going to extend the networking part of the event until 4:30. Just a brief note there. And then our next speaker is Ajay Kaladkar, the Technical Program Manager of Advanced Manufacturing and Industry 4.0 Solutions at RIT GIS Center of Excellence. His core expertise includes leading strategic digital transformations via Industry 4.0 solutions, Lean and Six Sigma implementation, leading capital projects for technological advancements, manufacturing engineering, and organizational culture change. Ajay, how are you?
Doing well, Steve. Thanks for having me.
All right. Take it away.
Thank you. Well, excuse me, I'm just trying to open the presentation. Having a little bit of difficulty finding the right tab.
And Ajay, I have the presentation up for you on my end if you'd like to continue.
Give me one more chance, Ben. I think this happened during our trial run as well. It takes a little bit of time to come up. Okay, how about we just go ahead with your solution there?
Okay.
Thank you. So my name is Ajay Kaladkar, and I am the Technical Program Manager for Advanced Manufacturing and Industry 4.0 here at RIT. Next slide, please, Ben. I don't know how much you guys know about GIS, but we've been around for 20 odd years, and most of New York State knows about the sustainability aspect of the GIS, but we also have 6 applied research centers focused around sustainable manufacturing and production. We have around 120 plus researchers on campus, and we usually have $15–16 million in sponsored external funding. So a lot of great activity. One of the staggering statistics here is that we have impacted more than 1,100 companies in New York State. So if you haven't benefited from our expertise, please do get in touch. Next slide, please, Ben. A sample of some of the projects we've done through our Center of Excellence here. Remanufacturing is a strong focus because of the sustainability aspect of the industry, as well as manufacturing process optimization, digital manufacturing, product development, design optimization. And we've worked really with small and medium scale manufacturers as well as larger names. And most of the rest of the presentation is focused around this digital manufacturing, but these are the other areas of the Institute as well. Next slide, please, Ben. So let's talk about COVID-19 a little bit. We had a set of priorities before the pandemic. We had probably most of the small and medium scale manufacturers were focused on growth, product innovation, lead times, time to market, cost effectiveness, and process quality. Pandemic gave us some significant challenges, unprecedented challenges in terms of cash flow liquidity, elevated risk to our human resources, severe supply chain disruptions in some cases, and that has appended the priority list post-pandemic. So now we have worker health safety as a new concern. We have cost effectiveness going up much further ahead because cash flow is important. Supply chain resilience wasn't a focus for us, but it is now. Growth and product innovation are still important, but I would argue that the other three take higher precedence. The good news is that Industry 4.0 is applicable as much, if not more, in post-COVID-19 priority list going forward. Next slide, please, Ben. Ben? Yep. So a bit of context on manufacturing. If you are to divide manufacturing, it's discrete and continuous, and further divide discrete into engineer to order, or make to stock, being cost effective has different kind of challenges depending on what your business model is. So generally speaking, as we go from left to right on this slide, the certainty of demand goes up and your product abstractness goes down. So it becomes kind of challenging to be cost effective. However, Industry 4.0 has applications across the spectrum. Next slide, please, Ben. Folks, before me have covered this, and I only have 10 minutes, so we can go ahead and skip this slide, Ben. So Industry 4.0 is a pretty wide and all-encompassing term, and it's important to dissect it and break it down into its individual chunks. And we believe the assessment framework developed by Singapore Economic Development Board does a great job at doing just that. So it's important to understand where the benefit can be and map it to the appropriate department in your organization. So we see 16 dimensions here on the screen, and it's really applicable to the 3 building blocks in your organization: the process, technology, and organization. The promise in terms of process is around seamless information exchange. How tightly integrated are your operations? How tightly integrated is your supply chain? And how much control do you have over your product lifecycle? The technology aspect is really the core of your value chain and how you're doing things. So automation, connectivity, intelligence, how much of the work is being done by machines, how connected these machines are, and how much intelligence are you driving from those connections. And organization part of it is really related to how smart your workforce is to transition from Industry 3.0 to 4.0, and how is your structure around collaboration and leadership to sustain the benefits you might gain from Industry 4.0. Next slide, please, Ben. So speaking of vertical integration, you receive an order, you typically have an ERP system, and you typically perform your work on the lower level with your machines. and there is an information flow from your ERP system to your machines. So vertical integration relates to how tightly integrated these different layers are throughout your organization, and how seamless is the information flow through them. If you receive an order and you do not have a manufacturing execution system or a SCADA system, or you do not have a flow to the right stakeholders within the system, it drives inefficiencies. So why care about vertical integration? Well, higher efficiency in making and implementing operational decisions, enabling analytics within the organization, and ultimately driving cost effectiveness is the reason you care about vertical integration. Next slide, please, Ben. Similarly, it's important to understand horizontal integration. Computer systems connected end-to-end, integrating customers, enterprise, suppliers into all one single homogeneous supply chain is extremely important. And folks before me have touched upon the aspect of how vulnerable our supply chains were pre-COVID era, and that kind of exposed us to some of the problems across the globe. So it's important to have visibility to build a resilient and a reliable supply chain, and Industry 4.0 holds that promise. So cost effectiveness for demand aggregation is something else that horizontal integration can help you achieve. And of course, if you are an organization that would like to share data with the customers on where the products are within the value chain, horizontal integration enables that as well. Next slide, please, Ben. The third thing here in terms of data exchanges is product lifecycle integration. If you are an engineer to order or make to order kind of company, you need a common information platform to integrate all the thousands of data points around your product. And I actually come from an engineer to order background, so this hits home with me. You have several hundreds of CNC programs, you have fixtures, you have molds, dies, you have manufacturing engineering data, you have design data. If you do not have a common platform, it kind of becomes extremely daunting to share information across your subsidiaries and your suppliers. So having a PLM system can hugely reduce the burden around driving engineering efficiency, speed, flexibility to meet growing need for personalization. Next slide, please, Ben. So, Ben? Yep. So next 9 dimensions relate to automation, connectivity, and intelligence. And I love the analogy Singapore EDB came up with to have automation depicted as the skeletal and muscular system in human body parlance. The connectivity dimensions are really your nervous system, and the intelligence dimensions are your brain. So how much of your work is being done by machines? How much of the operation is really connected to each other, and how much data are you drawing, and how much of that data are you using? That's the promise of these 9 dimensions. And we have seen Dan's presentation actually that gives a great idea on what robots and cobots can do in different situations. Similar promise is on the front end, where you have office and enterprise functions, where robotic process automation holds the promise of freeing up human capital for more engaging and creative work. And if you are a facility that has a large infrastructure, typically warehouses or retailers, you have these myriad expenses around maintaining the facility: boilers, chillers, parking, security. There's promise of automation in automating all of these aspects and optimizing them for driving cost effectiveness. Next slide, please, Ben. Connectivity and IoT is a focus in this era, because we have sensors and the technology is advanced to a level where we can pretty much monitor anything we want to. And interconnecting equipment and machines to enable communication and data exchange, it holds a large promise, because we have until now we had silos in different departments. Going forward, there is an opportunity to integrate all of that and drive intelligence and have a smarter operation. So increased visibility to derive higher operational efficiency is a promise that IoT in general and connectivity holds for us. Next slide, please, Ben. So I would argue that connectivity is really a means to an end. If you collect a bunch of information and do nothing with it, it's not of much use. But having artificial intelligence or processing and analysis of data to optimize existing processes is the real value of Industry 4.0, in my opinion. So we are at a point where we can probably look back and see what happened. So we have descriptive analytics, but Industry 4.0 can give you capability to understand why things happened. So go to a diagnostic level, move on to a predictive level to foresee what can happen in the near future. And ultimately, the holy grail is to go to a prescriptive analytics phase where we can understand how can we make things happen that we want to happen. So smarter asset maintenance through predictive analytics, optimized inventory, higher customer satisfaction through leveraging all these things is a promise that Industry 4.0 holds. Next slide, please, Ben. Of course, Industry 4.0 needs qualified personnel, and the framework has 4 dimensions for the human-related aspects of Industry 4.0. How good is your workforce learning and development strategy? How quickly can you move from Industry 3.0 to 4.0? How competent your leadership is to grasp all these myriad tools and implement it for your continued relevance and competitiveness of your organization. How strong is your intra-company and intercompany collaboration strategy? And do you have a digital-first kind of strategy and governance framework to execute the plan of action and identify opportunities in the long run? There are arrows here on this slide kind of show top and bottom because we believe 13 and 15 are really driven by the frontline operators and workers, while 14 and 16 are really a top-down kind of approach where management can drive Industry 4.0. Next slide, please, Ben. So a recap, 16 dimensions, that's a lot to talk about, but I wanted to give you a breadth of what Industry 4.0 can do. It's important to understand that there are 3 fundamental information exchange laws that have enabled us to come to this point. We've doubled our data processing capacity every 18 months or so. We've doubled our transmission capacity every 9 months or so. And we have doubled our storage capacity every 12 to 15 months. So that is a massive exponential change that industry faces. And all these foundational technologies are available out there, and there are products that leverage these foundational technologies to make an impact on your organization. And this is where probably GIS or RIT comes into picture with higher value proposition to make a quicker impact on your organization. Next slide, please, Ben. So I tried to simulate what the digital transformation journey would look like for a small and medium scale manufacturer. Left side here, you see that the company goes through an assessment with someone like us and scores on a scale of 0 to 5 on each of these 16 dimensions. And this particular example is for a job shop kind of environment where you have a bunch of machines, and connectivity, intelligence, and visibility is a really important thing. If you click through it, Ben, maybe a couple times, you can see year 1 scores and year 2 scores. So that's good right there. So it's important to prioritize what you want to work on. And Singapore EDB has fortunately given us a framework on how you can prioritize the opportunities you've discovered through the assessment. So firstly, we need to take what your current state is. If you're a lean practitioner, you're in tune with the PDCA kind of mechanism with identifying your current state, identifying what the future state vision is, looking at what the gaps are, and then creating a plan to bridge those gaps. This is pretty much the same framework with identifying your current state digital maturity in first step, identifying the impact to your bottom line as a second element, essential objectives for your business. So what are your KPIs, combining all that with your profit and loss statement. And lastly, if you have enough data available, look at where you stand in terms of your peer network in similar industries. To combine all these 4 elements, we can drive some prioritization exercise and chart a 3 to 5 year roadmap. So next slide, please, Ben. So ultimately, I just wanted to emphasize that this is a never-ending exercise, and really the goal would be to reach the highest level where you are in an adaptive phase, and you have a self-optimizing kind of manufacturing operation in an ideal state. So we see Industry 4.0 as something that is going to be around for a long time. Next slide, please, Ben. So a quick recap on what you can engage us for. We conduct comprehensive introduction to Industry 4.0 sessions for decision makers. We have an expert team that can conduct digital maturity assessments for you guys. We have some prioritization guidance where we can combine all these elements and help you prioritize what you want to work on first that can make most sense for the organization. And having done all that, we can also help you develop a strategic Industry 4.0 roadmap in the longer run that can help you chart the vision for 3 to 5 years. And of course, we're also here to help you with standalone R&D projects. If you have a project that is, that you're forced to implement because competition is moving in that direction, GIS has an expert team that can help you do that. So there's one more thing that's not on this slide. We just are in discussions with Digital Manufacturing and Digital Innovation Institute, now known as MXD, to develop a digital manufacturing ROI framework for small and medium scale manufacturers. So if you are a progressive company that wants to implement Industry 4.0, if you've made some decisions, if you have your own way of conducting ROI exercises, we would like to hear from you. So we would love for you to get in touch with us. Next slide, please, Ben. And if you do need contact information, the slide deck has this last slide that can help you get in touch with us over email. I would like to thank FuseHub and the fantastic team. Loved being a part of this event. Thanks, Ben. And thank you, everyone, for having me with this August lineup here.
So it appears that some people need to repeat things
again. All right. Jay, thank you. Our final speakers are Amanda Moore and Paul Burchmeyer from Design Systems Incorporated. Amanda is a proven business development professional with success in identifying business challenges and associated solutions at both the strategic and tactical levels. She's focused on lean principles, identifying opportunities for implementation of state-of-the-art technologies, increasing market share and cost reductions. Amanda is currently working on strategies for implementing Industry 4.0. As Industry 4.0 account manager for Design Systems, Paul works with companies to develop Industry 4.0 to meet their particular needs, helping customers identify their path to Industry 4.0 and what will bring ROI is critical. Welcome.
Okay, can everybody see my my screen? Are we good there? Let me see. Okay, we're good. So I want to give you a little history about the Design Systems, just a little background on us. So the company was founded in 1983. We were founded as a manufacturing, engineering, and program management firm. Today we have almost 300 engineering and technical support personnel. We are headquartered in Michigan, but we also have offices in Mexico and Canada, which allows us to be boots on the ground throughout North America. One of the things that has made us successful over the years is the ability to really create long-term relationships with our customers. About 85% of our business is repeat client business. The company was really, our roots are really in lean, process optimization, world-class manufacturing. These are just a sampling of the types of projects that we've done over our 37 years in manufacturing, really touching everything in the manufacturing and supply chain operations throughout manufacturing. One thing I do like to emphasize is that we are what I call technology neutral company. So it really doesn't matter, we're not pushing any one particular hardware or software. It really is what is best for the particular customer for their needs. So there's been a lot of discussion, AJ had brought it up, that Industry 4.0 is really, it's a vast animal, encompassing everything from digital twins to cybersecurity to machine learning, AI, all sorts. Where we are really focused in on is the manufacturing digital twin. And what we mean by that, it's really a virtual copy of your manufacturing facility. So that would be the facility, the equipment, the assets, and also the data. One of the reasons this is becoming, very, very popular with many of our customers, even before COVID. But one of the things that COVID has really driven is the fact that we do need to do more virtual collaboration. And in order to do that for many projects, we need to have this data online. We need to have an accurate representation of the facility. We need to have the ability to simulate and model in the digital world to do this type of collaboration. So when I talk about collaborating with projects, this is an example of the value of a digital twin. So we come in and we do a laser scan of the existing facility. We can then drop in any new proposed equipment. So you can look at, where are your clashes, what needs to be removed. From there, you can remove any material or equipment that will be eliminated, and you now have the future state of the factory. So this is where you can start your new modeling. You can put in work cells, you can put in assembly lines, you can put in avatars, showing all of your utility drops. It's really the future state of the facility. Then if you have any type of automation or coming through, you can also do a simulation on top of the point cloud. So once again, you're dealing with the real world state of that facility. So let's kind of take this bit by bit. One of the challenges of existing facilities, so many legacy facilities are still in 2D. Not everything is shown in 2D. You're not going to see all of your cable trays or everything that's on the shop floor. So it's very challenging to see exactly what's on there. So to address that, we have the ability to do a 3D laser scan. And what this is, it's a line of sight device that comes in and takes it, because it's line of sight, we have to take multiple scans throughout the company or throughout the facility and then stitch them all together. But this gives you the point cloud of exactly the exact conditions that are in the plant itself. You can work with this similar to the way you work with a CAD file, looking at specific layers, specific areas, really focusing in on what you need. The value of this is really to bring the entire project onto your desktop or laptop. It's bringing the field right onto your laptop. So no more multiple trips to the site. Once again, everybody can collaborate online with this. Here's a project that we did. This was actually for a small manufacturing company. They were moving from a greenfield or from a brownfield site into a new facility. Not sure why it's not going there. So what we did is we came in and we scanned the original equipment because they didn't have accurate models of their equipment. And then we came in and scanned the new facility, the new building. Let me see if I can get back up to that. Anyway, so we could scan and then model everything in the new point cloud. And I can show you another example of that. Here's another way that you can utilize a point cloud, and this is for modeling within the point cloud. So this was a package handling company, and they needed to put in a new conveyor system. So we modeled the conveyor system, actually put it into the point cloud. So once again, you're checking for any type of clearances, any type of clashes, clash detection. Additionally, all of the annotations that you see in there were actually in reference to the bid packs that were going out. So all the disciplines that we're going to be bidding on this particular work are looking at the same data sets. You can also, so what I've shown you before is the interior terrestrial laser scanning. We can also do drone photogrammetry and then integrate the two together so you've got one complete data set for the entire facility. So if you're doing something like roof penetrations or putting an addition onto the building, all the data is right there. So this is another example of that modeling within the point cloud. Most manufacturers now have 3D models available. So this is where you can do your trial. Rather than doing it on the shop floor, you can do it digitally to make sure that you can look at different iterations of equipment setups, making sure that everything is going to fit and act the way you want it to. this is another example of the what we call intelligent models that is part of the digital twin. So if you click on the particular element, that particular rail, you can pull up all the associated data or data associated with that particular piece of equipment. And not only data, you can also associate manuals. So what we're trying to do is to build a single source of truth for the entire plant. So no more trying to find manuals, trying to look up information, or spending a half a day trying to find one particular piece of data. It's all right there associated with the model. And there's the manual that you could pull up with it. So moving on to the next, what I would call building block of the digital twin is simulation. And many of these, so all of these technologies we've been working with for years, but they were kind of cost prohibitive for small to mid-sized manufacturing companies. It was mainly the large automotive companies that use them. But the cost of the technology, like every other technology, has come down. It's gotten quicker, faster, cheaper. So it's really applicable for just about any project. So what type of simulations can we do? Obviously, a throughput capacity. How can I increase my throughput? Looking at bottleneck identifications. A sensitivity analysis would look at, say, if, for example, if you are putting in one new piece of equipment that has a 20% increased production rate, how is that going to affect upstream and downstream? How does that affect the rest of the operation? Also, if you are moving from, say, which a lot of people have been doing in COVID, going from perhaps manufacturing parts into manufacturing PPE. So how can I put this new equipment on my shop floor? How can I make it all work, to its expectations? There's also some simulation studies that we're looking at doing to validate the 6-foot social distancing rules. How does, if I have to move everybody 6 feet apart, how does that affect my production throughput? So these are just some of the simulation studies that we've done. This particular one, the client had actually installed the equipment, and based upon, they've been around for 60, 80 years or something, so they thought they knew their business very well. They had estimated that they could get 140 jobs per hour with this new equipment. Well, after it was installed, they realized they were only getting 90. So they had us to come in to kind of do a retrofit, looking at the analysis of optimizing pallets. We also did some changes, engineering changes to the line. We put in, I think, a spur or two or something. But utilizing this simulation is how we could get them up to that 140 jobs per hour that they needed. We can also put the simulation into that point cloud that I talked about earlier. So if you can imagine, this is how you can get executive buy-off on a particular project, actually show people how it's going to operate in the real world situation. Where am I going to have my clashes? Do I want to really penetrate this wall to have it go through? Is this going to give me the throughput that I need? Once again, trying to do everything in the digital world so that we stop using the shop floor for trial and error. We can also do process simulation. So this is an example of a manual cell, and we can validate, the movements. We can validate the placement of materials. How can we optimize everything? Also looking at ergonomic analysis. Are we having people pick up too many heavy pieces at a bad angle? What is their specific line of sight in doing this particular operation? So it's not only the validation of the work in progress, but it can also be used as a training guide afterwards for quality improvement. So getting into kind of the another large piece of the puzzle, the digital twin puzzle, is the manufacturing execution system. And this is the production data. So what in essence it's doing is the tracking of raw materials through finished goods, the entire process. It's really the visualization of the production activity. And as we were talking about in the world of COVID, remote access is imperative. We can also use this to eliminate manual errors. If you have, say, paper work instructions, we can move them into electronic work instructions, or even a pick-by-light system. For quality control, we can look at genealogy and traceability. If you have an error part coming off at the end, can you trace that all the way back through what machining had been done, all the way back through to raw goods for quality control? And as we start gathering all this production data, especially the machine data, we can then move from reactive maintenance, which is, the putting out fires when something has gone down, into predictive maintenance. It's all about converting mass data into actionable intelligence. One of the barriers, MES systems have been around for years, but one of the barriers to them has always been that it's usually a very large enterprise-wide expensive system. And our approach to it is more of an agile. So rather than looking at this enterprise-wide system, we can look at even a machine at a time. So looking at a flexible, scalable, you can keep adding on to it. And our engineering resources can develop these use cases of how to use it, how to get more ROI out of it. These are some examples of some of the reports that we can give from the MES system, looking at actual downtime, what's really happening real time on the shop floor. And we've also developed an interface for any device, so you can have it on your mobile. Actually, one of our engineers has connected to his car, so he can see the data in the car. So that was kind of us in a nutshell. Let's see if I can go back.
All right, sounds good. Amanda, was that your last slide?
Yep.
Okay, very good. I understand that Paul's not going to present. So Amanda and Paul, many thanks for your time today. That was a great talk. And at this time, we'll begin the networking portion of today's event. You will be returned to the discussion table shortly. But before we start the networking portion, there are many COVID recovery initiatives being offered by New York State. Click the New York MEP sponsor link below to view what is being offered, or find us at the Fuse Hub table to help guide you. As part of the Manufacturing Reimagined series, in addition to the training provided by webinars and workshops like this event, there are also funding opportunities to support projects that help companies address certain COVID-related issues. In order to be eligible to apply for funding, manufacturers must request a resources report. This free report is a customized document put together after a discussion between you and one of our solutions experts to help identify NISTAR innovation assets and other resources that can help you to address issues that you're facing. It's really simple to request this report. Just click on the Manufacturing Reimagined link, provide us with your contact information and a brief description of what resource needs you have, and we'll get back to you within 24 to 48 hours. So listen, today's event takes place on 2 virtual floors, both of which have technical support tables and break rooms. There are general networking tables as well as the Q&A sessions with today's speakers. You can find them on the first floor. Then on the second floor, you'll find tables assigned to pertinent industry topics. We highly encourage you to use these tables to share relevant concerns and best practices. Also on the second floor, Connie Reichert-Lamort, Principal Engineer at the Edison Welding Institute, will be showcasing EWI's current remote robotic welding research. Craig Dory, Director of the Sesame Smart Manufacturing Innovation Center at RPI, will be available on the second floor to address your questions on smart manufacturing and discuss next steps to smart manufacturing upgrades at your facility. We at New York MEP look forward to seeing you there. We'll talk soon.